So some Common Stacks updates here. So I don't know if anybody has heard about Common Stacks yet, but this has been my life since about 2022, just thinking about how to do this. So it's been a short amount of time, and I think we're getting close enough now we can make a presentation on it. So here's my sort of classic intro slide. I'm a build engineer now, sort of slide. I have my email and GitHub on there. You can contact me in the Spack Slack as well. So let's sort of go over what this is going to be. We're going to start at the beginning, and we'll talk about what we're trying to accomplish, stack hierarchy, and some of the challenges around that. Some core features that we needed to make this possible in CI, and then how this actually ends up sort of applying to our CI workflow. So it started with too many pair views. Way too many pair views. When you looked at our build times and PRs, everybody was waiting for pair view. But it wasn't just pair view. We have a number of large packages and other long running builds that were blocking people. And we didn't really know if these were all needed. We didn't know if the variants were necessary. There were certainly variants that were not necessary. We had recently just removed the number of GPU targets and gotten a more than 10x speed up in some of our builds. And so another problem was reindexing. Our build caches were getting massive. We were at 32 terabytes, and our reindex was timing out after an hour. We needed to do something about this. This is too long, and people were not able to merge things. So we're asking ourselves, what can we optimize? What are people using? What are these stacks that we have actually testing and providing? And we were talking about splitting the repo and doing more releases, doing more snapshots. We're at 32 terabytes of build cache size. What's that going to mean? Because every snapshot and release was a full copy of every single thing in the cache. So this is going to be not great. So what do we need? We need to figure this out, and we need to build those things. Every single stack had its own copy to build cache, and they built the same things over and over and over again, exact hash matches. And so we wanted to deduplicate these, and additionally improve the reuse for people using our build caches. As they stood, some of them you needed the exact container to match, and it wasn't great. Another goal was to lower infrastructure cost. So this is just a top 10 list of cost per job for packages and how much time we spend building some of these packages. You see that there's a lot of overlap between these two things. We spend a lot of time building expensive jobs. And so this needed to be reduced. So stack hierarchies, you can call these sort of like user stacks, or I call them stack hierarchies. It's how do we build these stacks together to create usable binary caches. So we have some people working on this. It's a broad community effort. I don't think anybody's got what I would call the right solution, but we have a lot of solutions coming. So the HBSF binaries working group, I'm leading that right now. Here's our unofficial logo. I changed the numbers. It's HPSF 42. We're working on, how do we create these binaries? How do we make them usable in more places? How do we represent them better, sort of across the board? So it's not just for Spack, but Spack is definitely going to be one of the beneficiaries in this effort. Another one is E4S. So I'm sure a number of you have heard of E4S. This is Samir's project. They collect tons and tons of stuff, like everything you would ever need to build from Spack for scientific computing. They put it into these large environments, but these environments are very large. They're difficult to sort of manage and reason about at the concretizer level. And so you get some duplicates inside of these environments. And so we want to deduplicate, right? And so maybe we can help E4S through this effort. Pace of integration. So this is the opposite of E4S. These are very, very limited in scope. They have very targeted things. So data and visualization, tools, the XSDK, which is solvers and that sort of thing. And they focus on specific areas. And they try to make as much interoperability within those areas. And so this is zero duplication, unified environments. Another one that we've been talking to are the easy folks over in Europe. They have this layered approach. The two layers I'm most interested in this context would be the compatibility layer and the software layer. So how do we install on top of a system to keep things sort of on equal footing? And then how do we put software on top of that for folks and put that in our build caches? All right. So where Spack shines, we can take really high-level descriptions of what we want and light the fire of the concretizer, or the caramelizer, as I call it when I'm waiting a long time, and produce these sort of lock file states. And so this is a great illustration from Harman. I asked his permission to steal it. He said totally fine. And so Spack is really good at this. But as I mentioned before, with E4S, we get these large environments. We want to build lots and lots of things and use them together. It's sort of a dark art to make everything sort of reduce to the set of things you want. And the more dimensions you add, the more difficult this becomes. And so there are things you can do with version pinning, incremental concretization, environments together, bootstrapping off of other environments, then environment chaining as well. And so just a little tangent here. Back in 2022, I went on an adventure to minimize the number of HDF5s in E4S. I think there were 5 or 6. And they were mostly the same version, and I wanted everything to be 1.14. At the time, that was new. And so we turned on when possible, and lots of groaning from the concretizer. It didn't really work. Start version pinning things to bandage over the complaints. And then we found a lot of packaging bugs in this process. Things are over-constrained, under-constrained, the wrong variants are being specified. Variants are turning themselves off quietly. So this was a lot of effort inside of a large environment. And so I started thinking, well, what if we broke everything up? What if we had sort of a foundation layer that we defined? And then sort of this sort of intermediate layer from the foundation to these integrations that built a lot of the common tool chains, common workflow tools that we needed. And then on top of that, we just say these distributions, like E4S and Radius, they just use the things out of the lower stacks. We don't need to build everything again. We can just say, well, we already have these, and they're very well curated at these lower levels. Let's just use those. So right now, my main focus is in this foundation layer and the tutorial. The tutorial is special. And trying to get these to work the way I want them to. So this is sort of like, a lower level integration layer. And as I was doing this, I said, oh, we need features. I need to bootstrap compilers in CI. This used to be a feature, and then it wasn't a feature. And then we kind of went a period of time where we didn't have it at all, and then compilers as nodes came, and now all of a sudden we can do this again. Chaining environments, we needed better ways to do this. They didn't exist at the time. And for the binary cache, dependency holes, I'll explain this more later. And then stacks as projections, being able to combine build caches between our stacks. And so spec groups does a lot. Specs groups is my favorite feature for 1.2, if I had to pick, even above any of the ones I'm working on. We can do like real compiler bootstrapping in an environment, and we can do in a single environment incremental concretization. It is super cool. If you haven't tried it, it's worth looking at. We've already merged some stuff in stacks. So the ML stack is now one stack for Linux, which is super. E4S, there's some work to merge some of the stacks that we have for that. So this is very exciting. This is going to reduce sort of the integration level for us a bit. So the next thing is environment chaining. So there are different ways to chain environments. So one of them is through the build cache. So I create an environment, concretize it, install everything, and push it up to the build cache. And then in my next environment, I point at that build cache and try to reuse out of it. This isn't great if you have sort of wanting to do A and B really fast in consecutive order. And so there are other things we can do. You can do include concrete, or include environment, I think is what it's called now, where we take the lock file from env A, and we just shove it into env B, and we say now env A lock is inside of env B lock, and we get those things. This is not always desirable, though. You don't necessarily always want all of A in your environment. And so we have this other thing. You can reuse from an environment. And you can even filter the specs that you allow to be reused from an environment. And so this is very powerful. This came out of the include concrete stuff as Greg and I argued about what the behavior should be. So this is very cool. I'm just going to briefly talk about the relationship between a build cache and a stack before I talk about build caches, because I think the context is worthwhile. For every stack, there is a build cache, and it is one-to-one. And we don't allow pushing to multiple caches, and it's kind of ambiguous to do something like that. And we don't allow, but we do allow polling for multiple caches, but that's sort of neither here nor there. We call it build cache destination in CI. And it only contains what's built by that stack when we're talking in the CI context. So that's going to be important. For this, I told you, dependency holes. Let's talk about it. So if we break up our stacks and we layer them on top of each other, and one depends on the other, we end up with a problem. Build Systems wants to use the packages built by the foundation, but it does not have them in its build cache. And so when I go and try to pull things out of that build cache, I don't have them. And so I'm getting the 5-minute here. I knew this was going to happen. And so I'm going to go very quick through this because we already made a decision. But we came up with some ways to fix this. You could put more metadata in there and say this is exactly where the binary for this lives. This isn't super great for some reasons I'm not going to get into. You can put a deps.json inside your build cache and point it to the URL of the build cache that has dependencies that might be missing. The recursion problem for this when getting indices and stuff is terrible. Or you can do this thing called index views. So Todd alluded to this earlier, and that is what we chose to do. And it lets us use a mega cache. And so to use a mega cache, a single cache for all of our stacks, we need to solve this race condition when writing in the old format. And so on v1.0, we did the v3 content address tarballs. And so this lets us sort of idempotently write all of our specs in the blobs associated with blobs with the binaries and metadata associated with those. And so yes, build cache index views are a thing. There is currently a race condition for the append mode, which we will use in CI. This is getting fixed. We can do a push with lease sort of thing for S3 at least. And so that should be fixed soon.
Ryan, you actually have 15 more minutes. I screwed up.
Oh, I have 15 more minutes?
Yes.
Well, we're going to have lots of time for questions then, because I was really rushing. All right, so let's translate this to CI. I'll talk a little bit slower.
We have a break in 3 minutes. Yeah. On the schedule, it says it ends at 3
But this goes to 25. It's OK. All right. So in CI, what do we do? What's the workflow for CI? We generate pipelines. We send those off to a child pipeline. We build those things, sign those things, and then re-index the cache. If we have chained environments now that we're building in CI, we need to connect the generate step to the generate step of B to A. So these are these environments we were talking about earlier. But that's not good enough, right? Because we have those holes still. We need the dependencies from A to build B. And so we also need to have sort of a serialization of what stacks build when. So even if we can concretize right away, we need to wait until A is done building. I'm not super satisfied with this solution, but it will be the solution initially. But I have this idea, and it might be too crazy, but I want to merge and rebalance stacks. So GitLab has a limitation on how many things you can put into a pipeline. And it's the size of the expanded pipeline file. Once we get enough of these stacks, that pipeline file can potentially get really, really large. And so we could probably just pull all these together and then rebalance the problem. And we can maximize the number of things that build in parallel in each of these child pipelines. And we can sort of reorganize it this way. And so this won't be coming right away. I don't think we'll need it right away either. But this is something that will probably come. Some of the pipeline generation stuff that's happening for just an active environment may be applied to handle multiple environments and then create multiple layers of child pipelines. So this is a very simple diagram. I didn't want to get too much into it. So okay, so you're probably all looking at me like, Ryan, you're nuts. I don't follow anything you're saying, and if that's true, I'm sorry. I tried really hard to make this clear. But here we are. This is where we are now. This is a rough timeline until 1.2. We still have a few things that need to get done, like actually implementing the first step of the hierarchy of stacks. But all of the features we need to do this are merged, except for one. But it's very close. We're like on the precipice of actually being able to run pipelines or build cache pipelines in the farm that can depend on each other. So I did not change the title on this, but this is what's next, not where we are now. So after 1.2, index views are going everywhere. And everything is going to have an index view, and we will have a single mega monolithic cache that everything lives in. After that, it's all about expanding this, moving sort of across our foundation layer up into those integration layers, and eventually into the distribution layer, where we can have these nice sort of add this thing and you get everything, right? And as the stacks sort of become more complicated and more related, we're going to need more guidelines. So right now, you're a stack maintainer, and you're sort of allowed to let in or reject anything. When everything's related to everything, we now need to have a little bit more guidelines about how we maintain these things. We're wrangling this large beast. We're trying to keep duplication down. We're trying to use the environment chaining and Spack to have a more or less reproducible pipeline, but still keep moving it forward and keep testing all the things we want to test. And so that's going to need to come as well, but I don't have a clear sort of inclination of what that's going to look like yet. And so with that is what I got for common stacks.
Okay, so technically the break started 2 minutes ago. I'm not sure what happened with the schedule, but we'll take questions either way.
Can you hear this?
Yeah.
In the words of Bill Clinton, I feel your pain. I'll leave it at that.
Another comment, Ryan. The reuse of environments has been a lifesaver for us at Fermilab. So thank you, thank you, thank you.